Okay, so let's quickly go through the Laplace transform. Okay, so the Laplace transform is written as f of t is equal to what? Capital ST. Let's go with this one, equation 1. Okay, so now this one can be written as E t f of t dt. Let's call this one equation 2. Okay, good. Now let's define the terms in the equation. So where et st is the kernel. Okay, and f of t is the piecewise continuous function. Okay, good. Now Laplace transform, the purpose of Laplace transform is to transform a differential equation into an algebraic equation. Yeah. Okay, so now let us pick an example. Okay, example 1. We are trying to find Laplace transform of what? 1. So Laplace transform of what? 1 is equal to 0 to this. Then we have E st times 1 dt. Okay, good. So here from equation 2, our f of t is equal to 1. Then we just substitute into what? Equation 2. So that's what we get over here. So this is what we get from what? Equation 2. So now Laplace transform of 1 is equal to integral from this one to this dt. Okay, so now this is a common integral we do always. So from my previous video, whenever you want to integrate something like this, this is what you do. You take the power, which is negative st. So what you do is you differentiate with respect to t. So you're going to be differentiation of this dt. If you do that, you're going to get negative s. So this negative s you get, just divide it by this whole function. So that becomes what? The answer for this whole integral. So now we have Laplace of 1 to be equal to e this over what? Negative s. So don't forget your limit. So your limit from 0 to infinity. Okay, now we just put in the limit. So we have Laplace of 1 to be equal to e s, wherever we see t, we put in what? The infinity. Minus, we put in 0. 0 times any number is 0, divided by what? S. Now, as t goes to infinity, then this whole thing becomes what? 0. So we have 0. Any number raised to the power 0 is 1. So negative, which is positive. So we have 1 over what? S. So now the Laplace transform of what? 1 is what? 1 over s. Example 2. Laplace transform of what? A. Okay, so now from equation 2, from this equation 2, the Laplace transform of A, our f of t is equal to A. So we go back to equation 2. Wherever we see what f of t, we put in what? A. So our Laplace transform of A is equal to 0 to infinity est, then A dt. Okay, so this A is just a constant, so we just bring it out. So we have A, this est dt. So this whole thing is what we found from this side. So this whole thing is 1 over what? S. So we have A times what? 1 over what? S, which is what? A over what? S. So Laplace transform of A is A over S. Okay, so let's find the Laplace transform of what? Cos. Example 3. So Laplace transform of what? Cos t. Okay, so here our f of t is equal to cos t. Now we go back to equation 2 where we see f of t, we put in what? Cos. So when we do that, we are going to get Laplace transform of cos t equal to 0 to infinity e t, then we have our cos t dt. Okay, so now what we have to do here is what? We have two ways of solving this, but I prefer using what? Integration by parts formula. So you applying the integration by part formula, we have u dv equal to u v, then we have v du. Okay, so here from this equation, let your u be equal to, so I'll say let u be equal to cos t, and your v to be equal to dt. So here your v is equal to over s. Okay, yeah. So here du dt is equal to negative sine t. So my du is equal to what? Negative sine t dt. Okay, good. So let me go back to what? The Laplace, the integration by part formula. I call that one equation 3. Okay, so wherever I see u, I put in what? U, which is this. Whenever I see what? V, I put in this. Okay, then, okay, so let's go on. Okay, good. We are almost done. So we have est cos t dt is equal to, our u is what? Cos t, and our v is what? This. Don't forget your limit, 0 to infinity. Okay, minus 0 to infinity. Then we have what? V, which is what? est over what? Negative s. Then your dv, your du, which is what? This one. Okay, so that one give us what? Negative sine dt. So you're going to get negative sine t dt. Okay, good. So here, if you put in what? 0 over here. First of all, if you put in infinity, you're going to get what? Cos infinity e exponent s infinity all divided by what? Negative this. Minus cos 0 e raised to the power 0 divided by what? Negative this. Okay, good. Then here, this whole thing is what we've done over here. Then minus infinity 0 e st, then this. Okay, then we have what? Negative here. So let us make this one positive. Then what? Sine t dt. Okay, good. So here, this whole thing goes to 0. This whole thing, yeah, you could see this whole thing goes to what? 1 over what? X. Look at it carefully. This whole thing, so there is no negative over here. This whole thing goes to what? 1 over x. So we have 1 over s. Then minus, we bring this one out. So we bring this one out. So we have 1 over what? X. Something like this. Then t sine what? T dt. Okay, so this is where we've got into from this side. Okay, so now we also apply integration by parts again for this one, then we get a final answer. So if you do that, let's go and find this one somewhere and substitute it later on. Okay, so we are working on only this one. So here, integral from 0 to infinity e this, then we have sine t dt is equal to, let's call this one our u and call this one our what? Dv is equal to integral of this. So what I mean is that let's call this one t as sine t, and our dv is equal to integral of what? E this, then this, then our v become what? This over what? Something like this. So here our du dt is equal to cos t. Okay, so our du is equal to cos t dt. Okay, good. So this is what we are going to do next. So for our next step, so now our e sine t dt is going to be equal to, what's your u? Your u is sine t. What is your v? E this over what? Negative x. Okay, minus, okay, let's put in the limit, minus this. Okay, so now what is your v? This over what? This. What is your du? Your du is what? Cos t dt. Okay, good. So now this is what we have to do. We have to do something over here. If you look at it carefully, there's something you could see from this side. Yeah, there's something you could see from this side. Look at it carefully. So if you look at it carefully, you're going to get here, if you put in infinity, sine infinity times this one infinity divided by this minus sine 0, then es 0 divided by this, then minus, so minus, so that one become positive, then e t cos t dt. Okay, good. All divided by s. Okay, good. So this whole thing goes to 0. This whole thing goes to 0. Anytime t goes to what? Infinity, then this whole thing goes to 0. And sine of 0 is 0. So here we have just this part. So we have this over what? S cos t dt. So this whole thing give us what? This. Then now let's go back to this side where we see what? This whole thing. Let's put in what? This one. Okay, so let's go. So now we have 1 over s minus 1 over s, brackets open. Then we have integral from 0 to infinity e negative st all over what? S, then what? Cos t dt. Okay, good. So now this is what we have to do. We multiply to what? This one. So if you do that, you're going to get 1 over s negative s square, then this one e, this cos t dt. Okay, good. Don't forget that this is what we are doing. Cos t dt. Okay, so now this is what you have to do. You bring this whole thing to this side. If you do that, you're going to get integral from 0 to infinity e negative s cos t dt. This one is minus, so when you send it to the this side, it's going to be positive square this e this cos t dt, all equal to 1 over what? S. Okay, good. Next, so now we have common terms here that we can factor out. If you look at it carefully, we have common term here. So we are going to get e infinity 0, then e st cos t dt, open up 1 plus 1 over s squared. Okay, equal to 1 over s. Okay, good. So now let's divide both sides by what? This one. If you do that, we are going to, if you divide both sides by this, you're going to get e0 this cos t dt equal to 1 over what? This, then 1 over what? S squared. Okay, something like this. So here is the same as 1 over this divided by s squared plus 1 all divided by what? S squared. Okay, good. So now we have this e cos t dt equal to, this one is the same as 1 over s times x squared divided by s squared plus what? 1. Okay, good. So here, if you do that, you're going to get something like x squared all divided by s out, then s squared plus 1. Okay, so one of these s will cancel this one. So we are going to get s over what? S squared plus what? 1. So meaning that whenever we have, don't forget that where we started from what? Laplace transform of what? Cos t is equal to what? Integral from 0 to infinity est cos t dt. Okay, so this is what we are finding the Laplace transform. So at the end of it, we have what? Square plus what? 1. So meaning that the Laplace transform of cos t is always equal to what? S divided by s squared plus 1. Thank you.